Rationalize the denominator. All variables represent positive real numbers. We have here a radical expression. We have some radicals of z, and we have some radicals of x. And to rationalize this, I'd like to be able to get rid of those radicals. The way that we do that is we try and multiply by an appropriate choice of the number 1. And so by the number 1, what we mean is, of course, is something divided by itself, so that we're not changing the expression any. Multiplying by 1 doesn't change things, but what it does let us do is rewrite things. In essence, we're going to be shifting some of these root z's and root x's up into the numerator and out of the denominator. To do that, we want to multiply by whatever it takes so that this product and what I'm about to write down here don't have any radicals in it. The right thing to use is the conjugate of this anytime that we have a sum or difference of two things in the denominator, and we want to square the first bit and square the second bit. We use what's called the conjugate, and all that is it's whatever it takes so that we have a difference of squares here. So I take the root z, write it down. I take the 4 root x, write it down. And instead of addition, I'm going to do subtraction. Or if this had been subtraction, I would do addition here. I have a difference of squares. So now I have the first bit squared. I'm just looking at the denominators now. I have the first bit squared, root z squared, minus the second bit squared, 4 times root x squared. And the square root and the square cancel. I'm left with the z. Here, the 2, I gotta square the 4, gives me 16. I square the square root of x, square root and the square cancel, I'm left with an x. So z minus 16x is what my denominator is going to be. My numerator is going to get some of the garbage from down below. Remember, I have to multiply by 1, so I have to take and put whatever I put in the denominator in the numerator as well. And now we get to go ahead and do this multiplication. So let's do that. 4 times root x minus 2 times root z times root z minus 4 root x. Now we could go ahead and multiply these two things together. We could FOIL them out. But I want to ask you, why do you want to FOIL them out? Unless we have a reason to FOIL them, unless we have a reason to do that multiplication, let's not bother with it. Right? In general, we like factored form better than non-factored form anyway. So instead of multiplying these together, let's see if we can factor even more. And in this case, we can a little bit. There's a 4 here and there's a 2 here. So we can factor a 2 out of both of these two terms. So I'll do that. I'll take my 2 out. If I take a 2 out of the 4, I'm left with a 2. I still have that root x. Minus 2 times root z. I take the 2 out. I'm just left with the root z. Over here, I don't have any common factors, so I just left with the root z minus 4 root x. I'm going to leave that one alone. And so here's what we get as our final simplified, version of this radical expression. This version is rationalized. That is, the denominator is rationalized. That is, the denominator no longer has any square roots. The numerator has a bunch of square roots in it, but the denominator no longer does. If we did want to multiply it out, we just FOIL, and we could do that real quick. We could take 2 times root x times root z, and that gives us with a 2 root z x. We have 2 root x times minus 4 root x. That gives us a negative 8 times root x is x. We have a root z times a root z, negative root z times root z. That gives us a negative root z times root z is z. Negative root z times negative 4 root x is going to be a positive 4 root zx. And then, of course, times this whole thing, we got that 2 on the outside. So we have this. We could combine some like terms in the numerator, and we could multiply that 2 through. We have 2 root zx's and 4 root zx's. That's 6 total. Multiplied by 2 is 12 root zx's. We have a negative 8x times 2, so a negative 16x. We have a 2 times negative z, so negative 2z. That's all over z minus 16x. So we could do that multiplication, but it doesn't get us anything.